A student says if x squared is greater than 9, then x must be greater than 3. Determine whether or not this statement is true, giving a reason for your answer. You could do this algebraically. If x squared is greater than 9, that would mean that x squared minus 9 is greater than 0, which would mean that x plus 3, x minus 3 is greater than 0, which would mean, if we just drew a little graph with roots at minus 3 and plus 3, and our graph is bigger than 0 when x is greater than 3, or when x is less than minus 3. So the idea that x must be greater than 3 is false. That's not true. It could be less than minus 3. Alternatively, you could have figured that out yourselves by just thinking about an example where the statement was not true. You might have just thought, well, what about if x was a negative number? What about if x is minus 4, that's less than 3, and minus 4 squared is 16, which is greater than 9. So that's a counter-example to show that this student statement is false. So you can do it algebraically, or you can just come up with a counter-example yourself. Part II. Prove that for all positive integers n cubed plus 3n squared plus 2n is divisible by 6. So looking at this statement, I notice that each of those terms there has got an n inside it. So I'm going to factorise that n outside. And then I notice that I've got a quadratic that I could factorise some more. Two numbers that multiply to make 2 and add up to make 3. It's 1 and 2. And then I notice that there's something special about these three factors. They are consecutive integers. N plus 1 is after n, and n plus 2 is after n plus 1. So these are consecutive integers. Now, what that tells me then, so therefore, at least one of those must be even, because it's either going even, odd, even, or it's going odd, even, odd. At least one of those must be even. So therefore, at least one is even, and a multiple of, and that means it's a multiple of 2. Every even number is a multiple of 2. Now, the other thing about them being three consecutive integers is that there must be one multiple of 3 in there. If you think about any 3 consecutive numbers you can think of, whether it's, I don't know, 3, 4, 5, whether it's 11, 12, 13, whether it's, I don't know, 45, 46, 47, whether it's 85, 86, 87, whatever those 3 consecutive numbers are, one of them must be a multiple of 3, always. So if one of them is a multiple of 3, and at least one of them is a multiple of 2, when they get multiplied together, which they do because these are factors, the multiple of 2 and the multiple of 3 will make the result a multiple of 6. So therefore, the product will be a multiple of 6, and so will be divisible by 6. And we're done.